Welcome to Complexity Made Simple, and my name is Paul Allen. And before we get into today's fantastic video newsletter, what I'd like to talk to you about is all the materials that you can purchase to help to support the channel. We've got these fantastic textbooks that range from the simple statistical process control for small batch production. We've got the 7 quality tools for world-class problem solving, which is essentially yellow belt material. Then we move on to design of experiments for 21st century engineers. Every engineer and scientist needs to be able to do design of experiments. And then finally, drink tea and read the paper. The most fantastic green belt handbook you can buy on the market today, full of practical tips and fantastic physics that'll help you become a world-class engineer and a world-class quality engineer. Of course, you can also click on the link to buy me a coffee and make a donation. That would be fantastic. But at the very least, click on subscribe, click on like the video, because it all helps to support the channel. Many thanks for your help, and now on to today's video. Welcome to the latest video. And in this video newsletter, what we're going to take a look at is the meaning of independent variables in a design of experiments in a DOE. So this has been triggered by some comments that I've had, independent variables, on one of my videos where somebody asked me this question. So independent variables, and they said, is this important? So my answer to them was yes, but then what they came back with was something technically different actually to variables not being independent. So we're going to talk about what I mean by independent variables. So let's say you have a system. Let's say the variables are variable A, time, variable B, temperature, variable C, pressure. When we use the term independent variables, what we mean is these 3 are going to be moved alone on their own. The fact that I put the temperature somewhere doesn't force the pressure to be somewhere. So if I said I wanted to go time between 5 and 10 seconds, temperature to be 70 and 90 degrees centigrade, and pressure to be 100 to 200, we'll say bar in this case. Okay, so that would be my design space. So that's the design space that I want to interrogate. But because the DOE wants a certain pattern to be tested, I have to be able to put any combination of those variables into the system. So we've got a low setting and a high setting. So I can go low, 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 high, 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 or any other combination, low, high, low, etc. So I'm not constrained by the variables. That's what we mean by independent variables. Now, where a variable wouldn't be independent, where it's dependent, I'll give you a little example. A client of mine was trying to test a centerless grinder. Now, on a centerless grinder, there are 2 rollers that are effectively, they're set at a slight angle to one another, like this. And by setting them at a slight angle, that creates the drive force that drives the components into the machine. So one of the variables was how wide these rollers were set, how narrow and how wide. One of the other variables was the diameter of the component. And we reached a point where when the diameter of the component was small, but the settings were wide, what happened? The part falls through the rollers. Of course, it can't drive through the machine. They are not independent to one another. So they could be independent, maybe if I'd use different numbers. But if you use the wrong numbers, you can't set the small diameter with the wide angle on the rollers. That's not independent. And that's what we're talking about. Now, the person came back and said, actually what we find is that we have to move both variable A and variable B in order to get the setting that we want. Now, what we're talking about there isn't independence. We're talking about interaction. Actually, what they said, let me clarify, because I've just said that wrong. What they said was the ratio was important. So what they're saying is they could take the AB ratio as a variable rather than A and B independent of one another. Now, you could do that if you want to, but my view is, thinking about it, you're going to lose some information if you do that. So the way that we normally do this is to just run an ordinary DOE and let the interaction deal with it. So let me just take a situation where we're only using A and B. All right, so if we went, time was 2 and 4, temperature was 10 and 12. Let's do that. Okay, now you'll see, look, the ratio is changing. So here, look, there's a 5-to-1 ratio. Here there's a 6-to-1 ratio. Here, what's that? 4 in 10, that's 2.5-to-1 ratio. And here it's 4-to-12, which is a 3-to-1 ratio. So you can see that naturally in the experiment, the ratio is being moved. And what would happen here, that would show up, if that was important, as the interaction term. So in this DOE, what you'd end up with is y would be equal to the constant plus a term for A plus a term for B plus a term for the AB interaction. And it's the AB interaction that would account for the fact that these two variables, they interact with one another. So even though that person is saying the ratio is the thing that I'm interested in, that's okay. Let the maths do the work. The maths can see the interaction. The two variables concerned that were mentioned were independent, but what they were worried about was the fact that they interacted with one another, and therefore they didn't feel like going, what's the word? They didn't feel like moving them independently, because they felt like when they move one, in order to maintain the ratio, they ought to move the other one. But the DOE is perfectly happy with those three variables being moved on their own, and then the interaction will evaluate the fact that some kind of ratio is important. One of the issues I get, I think, with people thinking about DOEs, when I do a DOE, I'm usually asked into a company. I don't know the process. I have no prior thoughts or prior knowledge. So my thinking is not infected by prior process knowledge. When I deal with people inside companies, they've already decided, oh, this is important, that's not important, and they've already prejudged the situation. Much better to let the maths tell you the truth in a properly designed experiment. Because apart from the fact that it'll tell you the truth, it'll also quantify the numbers. So even though you go, oh, I think it's important, that's great, you could be right. But what a DOE will do is go, yes, it is important, but by the way, it'll move the result by 4 units. It'll remove the result by 1,000 units. It will actually quantify how important that piece of knowledge is. It isn't just a case of we have the knowledge. So, in summary, your variables are independent. The interaction is going to pick up the mathematical effect that you're worried about. Do the full factorial DOE. I think you've only got 3 variables, the comment that was left. You've only got 3 variables in your experiment. Do the DOE and let the interaction tell you the rest. If you have any questions about that, or you have any questions about designing an experiment generally, please leave some comments below. Contact me. I always love to respond to the comments, and I'm happy to make a video especially for you to answer any kind of special queries and problems that you think you might have. But for now, I'll see you in the next video.